Assalamualaikum. Hi everyone, I'm Cikgu Niswan. Okay guys, at the end of this video, you should be able to construct Born-Haber cycle for the formation of simple ionic crystal. An ionic compound is made up of charged particles called ions. It has a giant lattice structure with strong electrostatic forces of attraction. Example, in a lattice structure of sodium chloride, sodium and chloride ions are arranged in an orderly manner. Formation of sodium chloride solid from its ions called lattice energy. The lattice energy of an ionic crystal is the heat energy evolved or released when 1 mole of crystalline solid is formed from its separate gaseous ions under standard condition. Since it is bond-forming, so it is exothermic. Guys, lattice energy cannot be directly measured from experiments. It is impossible to bring together 1 mole of free gaseous cations and 1 mole of free gaseous anions to form 1 mole of ionic solid and measure the enthalpy change. However, lattice energy can be obtained by applying Hess's law in an energy cycle called Born-Haber cycle. The Born-Haber cycle must begin with the elements in their standard states. Based on definition, we need to form separate gaseous ions, then only it combine to form solid ionic compound. The step involved in the formation of gaseous ions from their respective elements consists of several steps. The steps involved in the formation of gaseous ions from their respective elements consist of the following. Atomization of the elements is a process to form free gaseous atoms. As you can see, sodium solid is changing to sodium gas and chlorine molecule gas is changing to chlorine gas atom. The next stage is formation of cation gas and anion gas. For cations, involve ionization energy, where the first ionization energy is the minimum energy required to remove 1 mole of electron from a free gaseous atom to form 1 mole of unipositive gaseous ions under standard condition. Whereas, for anions involve electron affinity. The first electron affinity is the enthalpy change when every atom in 1 mole of free gaseous atom accepts an electron to form a uni-negative ion under standard condition. So guys, now you should know to label enthalpy change or delta H on the energy cycle. Delta H1 is the atomization enthalpy of sodium. We have to produce gaseous atoms so that we can use the next stage in the cycle. Delta H2 is the atomization enthalpy of chlorine. Delta H3 is the first ionization energy of sodium. Delta H4 is the first electron affinity of chlorine. And finally, we have the positive and negative gaseous ions that we can convert into the solid sodium chloride using lattice energy labeled as delta H5. Now it is time to use Born-Haber cycle and apply Hess's law for calculating lattice energy of sodium chloride. The standard enthalpy change of formation of a compound is defined as the enthalpy change when 1 mole of the compound is formed from its elements under standard condition. I would like to label this as my first root to show enthalpy change formation of sodium chloride. Guys, flashback that Hess's law states that when reactants are converted to products, the change in enthalpy is the same whether the reaction takes place in one step or in the series of steps. The enthalpy change depends only on the initial and final states of the reactants and products, but is independent of the path taken. So, this is my root 2 to get to solid sodium chloride. As you can see, I start at the same starting point and reach the same ending point. Applying Hess's law, root 1 will be equal to root 2, so that enthalpy change of formation of sodium chloride will be equal to delta H1 plus delta H2 plus delta H3 plus delta H4 plus delta H5, where my delta H5 is the lattice energy of sodium chloride. We can determine the value of this Le, or lattice energy, by rearrange this relationship. Guys, it is very important for you to know to write the equation for each type of enthalpy change. Example, these are equations for convert sodium solid atom into sodium gas atom, convert sodium gas atom into sodium gas ion, convert chlorine gas molecule into chlorine gas atom, and convert chlorine gas atom into chloride gas ion. Alternatively, you can construct an energy level diagram to determine lattice energy of ionic compound. Still applying Hess's law, you can see that root 1 equals to root 2. Here, please take note some important points. In drawing energy level diagram, always start from the zero energy level. Positive delta H values are shown using arrows pointing upwards, showing increase in energy, while negative delta H values are shown using arrows pointing downwards to show decreases in energy. And each level should indicate only one type of enthalpy change. Since pointing arrow is very important to represent endothermic and exothermic reaction, you must know the enthalpy change involved for each step. Finally, mathematically, you can calculate lattice energy of sodium chloride is negative 776 kJ per mole. Guys, please bear in mind, the order that enthalpy change involved are written in the Born-Haber cycle is very important. They must be done in the order. First, ionization energy cannot take place before atomization because first ionization energy is the process of turning gaseous atoms into gaseous ions. And electron affinity cannot take place before first ionization energy since the electrons must be lost from the metal first during ionization to be present in order for the non-metal to gain them. From definition of standard enthalpy change of atomization and from the equation, it shows formation of one chlorine gas atom. Sometimes, questions don't give us enthalpy change of atomization of nonmetal because they can also give us the bond energy value for diatomic molecules like chlorine. Bond energy is the energy required to break 1 mole of covalent bond between two atoms in the gaseous state. So, if you are given bond energy of Cl-Cl bond, you must know how to modify the coefficient. So, if we are talking about bond energy, our reference point is chlorine molecule here, showing 1 mole of Cl-Cl bond is break and gives us 2 chlorine gas atoms. That's why the term for enthalpy atomization of chlorine must be multiplied by 2. For atomization, we have to follow the coefficient number of mole of atoms that we are forming. These two actually are the same quantity. Usually in question, you are either given enthalpy atomization or bond energy of nonmetals. Here we are given bond energy of fluorine-fluorine bond. Means we account for the energy required to break 1 mole of fluorine-fluorine bond to produce fluorine atoms. But we want to break only half mole of fluorine-fluorine bond to give 1 mole of fluorine gas atom. Thus, the enthalpy change will be half of the bond energy of fluorine-fluorine bond, equal to 79.4 kJ per mole. Here we have Born-Haber cycle for magnesium chloride. Guys, take note that the various enthalpy changes involved when going from elements in their standard states to their gaseous ions. Sometimes, successive ionization energies of the metal is applicable. Example, this is second ionization energy of magnesium. And be careful, you need to multiply the atomization enthalpy of chlorine by 2 because you need 2 mole of gaseous chlorine atoms. And you need to multiply the electron affinity of chlorine by 2 because you are making 2 moles of chloride ions. Now we have Born-Haber cycle for magnesium oxide. Guys, just focus on first and second electron affinity of oxygen. You have learned that the first electron affinity is the enthalpy change when every atom in 1 mole of free gaseous atom accepts an electron to form a uni-negative ion under standard condition. Second electron affinity of oxygen is when an electron is removed from uni-negative or minus ion. Note that the arrow for second electron affinity of oxygen pointing upwards. This is because second and higher electron affinity are all positive. That's all for today, students. See you in the next section. Bye!